Welcome to the deep dive. Today, we're plunging into some really fascinating source material. It's all about the cutting edge of training large language models.
Hmm.
We're zeroing in on this new idea, something that could, you know, fundamentally change how these models learn, make them better at complex stuff like reasoning right from the start.
That's right. The core concept we're unpacking is called reinforcement pre-training, RPT for short.
RPT, got it.
And our source, it's mostly excerpts from this pretty compelling research paper. It lays out the idea, but also shows some initial results that, well, they really make you think.
Yeah, because you think about it. Standard LLMs, they're already incredibly powerful, right? They generate amazing text.
For sure.
And that power comes mostly from that initial training. But the question is, how do you get deeper understanding, real reasoning ability baked in from the beginning, not just tacked on later?
Exactly. And that's what this deep dive is about. How RPT tries to tackle that challenge head on, right, in the pre-training stage.
Okay, so before we get to RPT, maybe we should quickly cover the baseline, how LLMs are normally trained.
Good idea. So the standard approach, it's called next token prediction, NTP.
Right, and that's pretty simple on the surface, isn't it? You just feed the model tons and tons of text,
Massive amounts.
and its only job is to guess the very next word or token.
Exactly. It sounds simple, but it's incredibly scalable. And just by getting really good at that one task across, terabytes of internet text, these models implicitly learn grammar, facts, relationships. It's quite amazing, really.
That's the foundation.
That's the foundation. It powers their general language skills.
Now, we do hear about reinforcement learning, RL, with LLMs, but that usually comes later, yeah, after this big pre-training phase.
Precisely. Most people know RLHF, reinforcement learning from human feedback.
Right, for making them safer, more helpful, aligning them.
Yeah, aligning with human preferences. But the big catch there is you need lots of expensive human-labeled data. And sometimes, you run into this reward hacking problem. The model gets clever about maximizing the reward signal in ways you didn't intend.
Okay. And there's another type, RLVR.
Yes, RL with verifiable rewards. That sounds a bit more robust, maybe.
It is, in a way, because the rewards are based on objective rules, like, did it get the math problem right?
Yeah.
Is the answer factually correct according to this database?
Okay, so less subjective, much less. But the limitation is right there, verifiable. You need specific data where you can verify the answer, often annotated data, which means it's great for teaching specific skills like math or coding or checking facts in a specific domain, but you can't really apply it to that huge, messy, unannotated web text used for the initial pre-training.
Yeah.
It just doesn't scale or fit.
So, okay, we have this powerful, goal-driven RL thing over here, but it needs structure, verification. And then we have these massive unstructured text data sets over there.
Right, the standard pre-training fuel.
That give us general ability. The big challenge is, how do you bridge that gap? How do you get the goal-directed power of RL working on that general unannotated data from the get-go?
And that right there is where RPT comes in. It's proposed as this novel paradigm specifically to connect those two worlds.
Okay.
It essentially brings RL, specifically the verifiable kind, right into the fundamental next token prediction task itself.
Whoa, okay. How does that work? How do you make simple prediction into an RL problem on just raw text?
So the core idea, the real innovation, is reframing the task. It's not just predict the next token, it's more like reason about the next token.
Reason about it.
Yeah. Instead of the model just spitting out the next token, RPT prompts it to generate like an internal monologue first, a chain of thought, a reasoning sequence before it makes its final prediction.
Ah, okay. So it has to sort of think out loud internally, even for just predicting one word.
That's a good way to put it. And the genius part really is the reward. It's super simple, verifiable, and uses only the original text data.
Yeah.
The model gets a reward, let's say 1, if its final predicted token is correct, meaning it perfectly matches the actual next token that was in the original document.
The token that was already there. Seriously.
Exactly. If it's wrong, reward is 0. The source calls it a prefix matching reward. If your prediction is the correct start, you get the point.
So you don't need any extra human labels, no special annotated data sets for this part.
None at all. You're using the inherent structure of the text itself, what word actually follows what, as your verifiable reward signal for RL.
That's actually really clever.
It is, because suddenly you can apply this goal-oriented RL training to the entire massive web-scale dataset that you'd normally use for standard pre-training.
You're turning all that raw text into a gigantic RL training ground.
Pretty much. A massive source of supervision for general-purpose RL, right at the most fundamental level, predicting the next token, but with reasoning involved.
Okay. My mind's spinning a bit. Let's dig into what the researchers actually found. What are the benefits they saw when they trained models this way?
Well, the first big one, as we kind of just covered, is scalability and generality.
Right. Uses the same data.
Exactly. No need for new, expensive, bespoke data sets. It works on the same stuff as standard pre-training.
And the reward being verifiable. You mentioned reward hacking earlier.
Right. Because this reward is so simple and rule-based, is this token the correct one? Yes or no? The risk of reward hacking is much lower. It's harder to game than a complex learned reward model.
Makes sense. And the reasoning part. Forcing it to generate that chain of thought, what does that do for the model itself?
That's maybe the most interesting part. By explicitly making it generate that internal thought process, RPT seems to encourage deeper understanding and better generalization.
How so?
Well, the idea is it's not just learning surface-level statistical patterns anymore. It's learning to explore possibilities, weigh the context, maybe validate hypotheses internally about why a certain token should come next.
So it's practicing exploration and validation.
Kind of, yeah.
Yep.
Fostering that internal process.
It's like it's being forced to think more about each prediction during training.
Exactly. The paper actually uses that phrase, training time thinking. It means the model effectively dedicates more computational effort, more thought, to each token prediction it learns from.
And the hope is that builds a stronger foundation.
That's the hypothesis. A more robust, capable foundation compared to just rapid-fire pattern matching.
Okay, conceptually, it sounds powerful. Did the experiments actually bear this out? What were the results?
Yeah, the results they shared in the source material, they're quite striking. They trained a 14 billion parameter model with RPT and compared it against standard methods.
How did it do on just basic next token prediction, the thing it was trained on?
It showed significant improvement, especially on the harder predictions. They had this category of hard tokens.
Okay.
And the RPT-14B model got over 23% accuracy there, compared to around 20% for a standard 14B model just trained with predictions.
So a noticeable bump where it matters most.
Definitely. And maybe even more impressive, they found that this 14B RPT model actually matched the average next token prediction performance of a much bigger 32 billion parameter standard model.
Wow. So more bang for your buck, parameter-wise.
Seems like it. Suggests RPT is making the model more efficient, more capable per parameter, which, in the world of LLMs, efficiency is huge.
Absolutely critical. Did it keep improving as they trained it longer with more compute? Does it scale?
Yes, that looked good too. The results showed its accuracy improved consistently following a predictable power law curve as they increased training compute.
That's important. Predictable scaling.
Very. It suggests it's not some fluke, but a potentially reliable strategy for building even bigger models down the line.
Okay, so it's better at the fundamental task, seems efficient, scales well. What about using it for other things? Is it a better starting point for, say, fine-tuning later?
They tested that too. They took the RPT pre-trained model and a standard pre-trained model, and then fine-tuned both using that RLVR method on a separate task, needing verifiable answers. The difference was dramatic. The RPT-based model achieved 58% accuracy after the RLVR fine-tuning. The standard model, only 13%.
Whoa. 58 versus 13.
Yeah. It suggests RPT created a much, much stronger foundation for that kind of downstream RL tuning.
That's a massive difference. Okay,
Yeah.
what about just general reasoning out of the box?
Yeah.
Zero-shot performance, no extra tuning.
This is where that reasoning aspect really seems to pay off. They tested it on some tough benchmarks designed for broad knowledge and reasoning, things like Super GPQA, MMLU Pro.
Yeah.
And the RPC-14B model significantly beat not just the standard 14B baseline, but even the standard 32B baseline in their regular evaluation mode.
The 14B RPT beat the 32B standard.
On these reasoning tasks, yes. For instance, MMLU Pro, the RPC-14B scored over 71%. The 32B standard model was down around 56%.
That is genuinely impressive, getting that much more reasoning power just from changing the pre-training objective.
It really points to the potential impact of building reasoning in from the start.
So how did they figure out how it was reasoning differently? Did they look inside the thoughts?
They did. They analyzed those chain of thought sequences the RPT model generated internally before making its predictions. They looked for patterns, keywords, trying to understand the process.
And what did they find? How did it differ from, say, a model trained just for problem solving?
It was quite distinct. Compared to models trained explicitly for step-by-step problem solving, the RPT models use patterns associated with hypothesis generation and verification much more.
Hypothesis.
Yeah.
Like considering possibilities.
Yeah, exactly. Thinking through options. And also using deduction more. They relied less on just breaking down a problem rigidly.
Can you give a flavor of that? What does that internal hypothesis thinking look like in practice?
Yeah, the paper had an example from mathematical text. The model's trying to predict the next token. Its internal thought isn't just calculation. It looks more like deliberation. You see steps where it's analyzing context, maybe brainstorming options, like common phrases after this could be X, alternatively maybe Y, then checking structural clues in the sentence, and using all that to deduce the most likely next token.
So it's not just pattern matching the most frequent next word. It's more like internally debating, weighing evidence.
That's the feeling you get from the analysis, yes. A more multifaceted process, considering meaning, structure, possibilities, all to reason its way to the prediction. That seems to be the qualitative shift RPT encourages.
Okay, let's pull this back to the listener. For you listening, if AI models start being built like this, trained from day one to reason about information, not just predict patterns, what does that actually mean?
Well, think about the kind of answers you might get. Is it just plausible text based on statistics? Or is it the output of something with a more, let's say, robust internal reasoning process?
Right. Could it lead to more reliable outputs, more thoughtful generation?
Potentially, yes. An AI built on this kind of foundation might have a deeper grasp, leading to outputs you can trust more or that show more genuine understanding.
And if you're someone trying to cut through noise and get solid information quickly, an AI that reasons better internally could be a much more powerful tool. Maybe more transparent, or at least more robust in how it gets you insights.
It's an exciting possibility. But of course, we need to be realistic. The source material itself points out this is early work. There are limitations.
Right. What were the main ones they mentioned?
Well, the key experiments were mostly on that 14B model. They haven't yet shown this scaling up to, the truly giant models yet.
Okay. Size matters here.
It does. Also, while the method should be general, the data they used for these specific tests was heavily weighted towards mathematical text.
Ah, so maybe it works especially well there. Needs testing on broader data.
Exactly. And the starting point, the base model they built RPT on top of, already had some basic reasoning ability. They didn't start completely from scratch with a dumb model.
Gotcha. So promising results, especially on reasoning, but need to see it scale up, work on diverse web data, maybe starting from simpler models too.
Precisely. And that's what they say they plan to do. Future work includes scaling RPT to much larger models, using general internet data, really nailing down the scaling laws, and maybe even exploring ways to make the internal thinking more adaptive.
Well, this has been a really, really interesting deep dive. It definitely challenges the standard way of thinking about LLM training. Thanks for walking us through reinforcement pre-training.
Absolutely. It's a fascinating concept of thinking about embedding reasoning so early.
It really is.
Yeah.
And it leaves us, and you, with a pretty big thought to chew on. If the very foundation of how we train these powerful AI models shifts from just predicting what comes next to actively incentivizing them to reason about every single piece of information they process, what new level of understanding, capability, maybe even intelligence could emerge? And how might that change everything about how we find, process, and interact with knowledge in the future?